Hey y'all, it's me, Miss B. Today we're talking about solving systems of linear equations, and it's combining two ideas that we've learned recently. It's combining graphing linear inequalities and solving systems of equations by graphing. So what you do is you graph the linear inequality, both of them, and then that shaded area, the place where it's shaded both regions, is where the solution is. So it says the solution to a system of linear equalities is where the two shaded regions overlap. Okay? In other words, the doubly shaded is what I'm going to call it, region, or I guess it doesn't want me to say that. The overlap of the shaded regions is the solution. So these two things say the same thing, just two different ways. Okay, so jumping right into some examples. So to solve, we want to graph each of these separately and then see where the overlap is. So here I have x minus 2y is less than or equal to 4. I'm just rewriting it so that I can rearrange it and get y by itself. So go ahead and do that. What you should have got was negative 2y is less than negative x plus 4. Divide both sides by negative 2. You get y, I changed my sign first of all, is greater than, oh, dang it. We have to flip our sign because we divided by a negative, so y is greater than or equal to 1/2 x minus 2. We do want a solid line, and also we're going to be shading above because of that greater than symbol. So here's minus 2, up 1 over 2. We have a solid line, and we want to shade above. I do suggest using colored pencils, that way you can see more easily where that overlap is. Okay, then we're going to graph the red, so I'm going to go down 4 on my y-axis and then up 3 over 1. I do have a dotted line, and it's also shaded above because of that greater than symbol. So, dotted line. Use a straight edge so that way you can make sure your lines are super straight. And we want to shade above. Okay, so then what the heck just happened? I don't even know how I did that. It's funny. Okay, so that overlapped region in the purple is where our solutions are. So the three solutions, for instance, 0, 0 is a solution. And I want you to go ahead and name two more solutions. Okay, so you could have had a lot of different answers there. There are infinitely many solutions to the system. All right, next up here, go ahead and graph this line. Well, first, you know what? Let's write it in terms of y, 2x plus 3y less than 6. So I'm going to subtract 2x from both sides, then get 3y is greater than negative 2x plus 6. Divide by 3. Get y is less than negative 2/3 x plus 2. Take a minute and get that work down, and then go ahead and graph it yourself. You should have had is minus 2 down 2 over 3. That is down 2, not up 2. Yeesh, up 2, then down 2 over 3. So our line is going to be dotted because it is doesn't have an underline. and we want to shade below because it's a less than symbol. So here is our graph of the red. Then for blue, go ahead and graph that one. We're going to go up 4 and then down 2/3 again, but with a solid line. Should put arrows on this one, and I just didn't. Okay, and then we want to shade above. You'll notice that there is no overlap, but that's where the solutions lie. So there are no solutions to the system because of the fact that those lines are parallel and they don't, and their inequalities go different directions. All right, I want to go ahead and try this next one on your own. So what you should have done is in blue, you want to go down 4 and then up 2/1. We do have a solid line because of the fact that it has an underline, and we're going to shade below. All right, then red, we're going to go up 4 on our y-axis and then down 1/1. We want to have a dotted line. And then we're shading above this time. Okay, so I'm actually going to ask you whether things are solutions. So first up is 0, 0 a solution? Is 6, 0 a solution? And is 4, 0 a solution? So 0, 0 is not a solution because it's in no man's land. 6, 0 is a solution. It's in the doubly shaded region. And 4, 0, because it lies on that red line, is not a solution because it's on that red dotted line. All right, so next up, we have our final example. So it says you're planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball, but you must spend at least an hour and a half on homework. What is the graph showing how you can spend your time? So we're going to write 3 linear inequalities. I'm going to go ahead and highlight what they are. So here it says you can spend at most 6 hours daily playing basketball and doing homework. So you only have 6 hours of time you can spare. Then you want to spend less than 2 hours playing basketball, but you must spend an hour and a half on homework. So let's first start with our orange. I'm actually going to label what these points are. So let's call X basketball and Y homework. So let's label, this is homework. And this is basketball. Okay, so starting with our orange, you can spend at most 6 hours daily playing basketball and homework. So I'm going to have X plus Y, and 6. At most. Does that mean I can play 6 hours? Yep, it does. Can I have any more than 6 hours? No. So 6 is as big as it gets, so our inequality is going to be less than or equal to. Next up, I want to spend less than 2 hours playing basketball. So X is basketball in 2 hours. So I'm going to eat the 2 because I want to be less than 2. Finally, 1 hour and hour and a half on homework. So Y and 1.5. And I need to be at least an hour and a half. So I need Y to be greater than a half, not equal to. Oh, wait, and equal to. Sorry. Because at least. Okay, so then let's start graphing. So X plus Y is equal to 6. I'm going to rewrite that equation as Y is less than or equal to negative X plus 6. So it's easier to graph. Here's 6, and then down 1 over 1 for that. So there is my line. And I want to shade below. Okay, then X is less than 2. So here's my X equal to 2. And I want it to be a dotted line. So there's that. And I need X to be less than. So less than is going to be to the left over here. Okay, then finally Y is greater than or equal to 1.5. So here, I think I did no, we're good. 1.5 is here. And I need it to be equal to, so solid line, and it needs to be greater. Okay, so it might be kind of hard to see, but this region right here is the portion that got triple shaded. Now that's where the solutions lie. I want you to go ahead and rate 1 to 5 how well you understood today's lesson. Where 1 is I have no idea. 3 is I need help from Miss B. And 5 is I can do it myself. That's all for today, folks.